Hey, welcome back. We're still on section 4.2 and now you're starting a new OneNote of questions. Okay, stick with it, you're nearly there now. Use your calculator to evaluate each of the following to 2 decimal places. Right, I'm going to be using 2 decimal places a lot, so it's time to fix my calculator. I'll make sure to show you the one most of you have. So we're going to go into... I did TumTum. See, this is something when I'm on the computer I could never say TumTum. So we TumTum, and we go with option 6, and we go with option 2, 2 decimal places. Okay, and now the first one is root 19. I'll do that again. Root 19 shift equals. Okay, 4.36. I'll just write down answers. Going straight down the page now. The next one is 2.75 to the power of 4. Okay, I forgot. Okay, this is equal to 57.19. It's not, it's approximately equal to 57.19. But you're never going to know it exactly unless you write it as... Oh no, that's not true. Okay, it is... Because it's rational, then its power 4 is rational. Anyway, let's not go on about that now. Now there is a button for cubed root, so we're going to use it. It's that button. You can only barely see it here, but I can certainly see it there. My eyesight isn't as good as yours as well. So you're keying in 28, you're doing shift equals... And guys, I'm going to get better at just being in here in the trenches with you and doing it the way you have to do it for the exam. Because using the technology I use in class doesn't show me every nook and cranny and little nuance of what you have to, the full skill set you're developing. So let's really get to it down here in these videos and appreciate that they are probably even better than using suave presentation on a computer screen. Suave the right word? I don't know. But anyway, 13 to the power of a quarter. Well, the quickest way, I could put a quarter in using the fraction bar, but it's an easy decimal. Okay, and that's the exact same thing. 1.9. Now that's 4 values, the way they're laid out. So I'm going up here now, and this is 39 to the 3/4. 39 to the power of 0.75. Now in the exam you won't be given a whole plethora of stuff to do like this, but here we are given it, and we're going to have to learn to get fast, and the speed you develop here will pay dividends when you're under pressure in an exam doing problem solving. Okay, now 3.42 to the negative 3. I might as well just let the calculator do everything. I could start applying some rules. I could go 1 over 3.42 cubed, but why would I bother? 3.42 to the power of negative 3 shift equals 0.02. Now they said they only wanted the 2 decimal places. There's a richness of data going on out here, but I'm following instructions, so I'll leave it at that. 26 to the power of 0.75 is 11.51, and 42 to the negative 7/8. 42 to the power of negative 7/8. 7/8 is 0.875. But am I sure? Well, let's give it a go. Write down the answer and then just swing back and check. First of all, no, that can't be right. I did something wrong. Because it's like 1 over 42. It should be way smaller than that. But I think that's because I keyed it in wrong. 42 to the power... I must have put it into the power of 7/8 to the power of negative. In all my talk about getting the fraction bit right, I left out the sign. So 95% of my brain was absorbed with explaining to you the fraction, and that was the rock I perched on. Isn't cognitive science fabulous? Okay, now I'm going to try and get it right this time. So It's 0.875 is, to the best of my knowledge, 7/8. Pretty sure, because 0.125 is an eighth, and that's it away. Okay, so now it's very important that you know that I knew there was something wrong here, and you'd have to have a number sense. This is almost like 1 over 42, so it has to be very small. 0.04, now that's shouldn't be presented like that. And if I took off the limitation of the 2 decimal places, we'd see more richness. And as I say, let's do it the other way just to be sure. 42 to the power of negative, and here we go to fraction power, and I'm going to go 7 upstairs, downstairs for 8. And I hope you can see that properly on the video. I'm just making sure the light catches it right, and freeze framing or holding it there for you for a second. Okay, and then shift equals 0.04. And so that's, there isn't a fifth root in this way, so we're going to have to use that as a fifth. So I have to convert that to 34 to the fifth. Okay, and then I have a choice. I key in the 34 first. By the way, you can key in. You can push that button first, then key to 34, and then move upstairs. But that's more complicated than going 34 risen to the power of. So make sure you're keying in the base before you decide I want to make that an index number. And a fifth is 0.2 every day of the week. You get 2.02. And then there's only one to go, isn't it? 6th root of 100. That's a 100 to the power of a 6. If you want me to be real suave, cheeky, I go the 6 reciprocated. Now the reciprocation is up here, x minus 1 on this one, and on this one the reciprocation is down here. So there's a swap depending on what one you're using. And I'm going to go 6 reciprocated. Ooh. It's 2.15. Oh, that's cool. And then doing it just to say, well, why can't you just do it to the power of a fraction? Because that's what we're used to. Yeah, don't be afraid to learn new things. If it's a unit fraction, that x to minus 1 is really handy. Same answer. Okay, so check it out again. 100 to the power of, where is it? To the power of a 6th. If you want the 6th, you can press 6 upside down. Okay, take it or leave it. It's a gold nugget though. Number 13. Okay, number 13. Write the following in the form of 2 to the power of something. There is a method. If you won't learn this from the book. There is a method. So I'm going to rattle them out. And you go, but you know everything in your head. You've them all learned off. So I'll do it. I'll just kind of tell you this is because I happen to know the answers because I know my tables and I know my powers of 2. But then again, I spent years and years teaching and learning them off so that I wouldn't have to look them up while I'm up at the board. So do you do that when you've 2 years to prepare for an exam that you're being forced to take or whatever? Maybe not. Maybe there's a difference between my standards for me and what my standards and what I tell you should be learning. Okay, now the power of 2, that's 2 to the minus 1. A power of 2, that's 2 to the third. I'm going to show you a way to calculate all these without any question in a second on a calculator. Okay, quarter is 1 over, so a quarter is 1 over 2 squared, which is, so I want to bring that up and it becomes 2 to the minus 2. And 1 over root 2, well first of all it's 1 over 2 to the half. When you bring it up it becomes negative. Whoops, negative a half. So they're the answers. But I don't expect you to know them. So, well, how are you supposed to find them then? It's a button up here called log. And it goes like this. Let's take the 32. You can go log to base 2 of 32. Now we'll do this for everything. The number they're giving us here goes last, and to base 2 goes here. The answer is going to be 5. What? Yeah. Even though you don't technically have to study logs, logs are an opposite to a squaring, to exponentiation. Just a fancy word for indices we're doing now. 5. Okay. The only reason this is 5.00 is because I got it in fixed mode. But there is nothing out there. Okay. We'll do the same thing for square root of 2. Log. No, not log, by the way. Yeah, not. How do I get log? Log with a given bit. Now I've pressed twice. Log 2 of root 2 is a half. Cool. Log to base 2 of, and come forward into 8, into the bracket, is 3. Log 2, jump forward a half, is -1. Log 2, jump forward cubed root of 2, and is a third. Okay, down to the 16. Log base 2, 16 is really a power of 4. Change that to a quarter. Answer will be -2. And change that to 1 over root 2. Answer will be -1/2. Okay. More about that later. We might need that from time to time. I think you're going to need it actually in the next section. Even though I don't think it's technically going to be taught to you. And they're going to show you a kind of working backwards intuition method. But don't worry, you'll be okay for the next section. I'll take you through it step by step. Now, question 14 next. Write each of the following. So here we are. Here's the same old ding dong here. So I'm going to write out the answers quickly, and then we're going to produce them on the calculator as well. So 3 to the power of something gives 1. Well, anything to the 0 gives 1. 3 to the 4 gives 81. 3 to the half gives root 3. 3 squared gives 9. 3 to the -1 gives a third. 3. Now, I'm going to want 3 for 27, but I'm going to want 2 for the fact that it's a square root. 3 cubed gives 27. 3 to the -2 gives a ninth. And 3 to the -1/2. And it's going to be the same thing down here, so let's do these as well. 5 squared, 5 to the 0, 5 to the half, 5 cubed. 5 to the -2. And if you're struggling, if you're finding this difficult, honestly don't worry about it. You can, that's plus a fifth, you can get by. It's a small part of the whole exam. 5 to the -1 and 5 to the -3. It's a square root, so you'd expect it to be half, but it's underneath, so it's -1/2. Okay, God, they never stop. I'll swing back and do some of these. So it's some of these on the calculator as well. 10 to the -1, 10 to the -1/2, 10 cubed, 10 to the -3. Let's do this in stages. 10 to the half over 10 to the third. A half take a third is a sixth. 10 to the sixth. 1 over 100 is 10 to the -2. 10 to the half. And this is sort of torture, isn't it? 10 to the 3 over 2. I mean, even when you're able to do them, and I'm really able to do them, it's still, that's when it even gets worse. Okay, 10 to the 100th. 10 squared over 10 to the half equals 10 to the 1 1/2 equals 10 to the 3 over 2. Oh, yuck. And that's that done. Now there might be some questions here where it's kind of more conceptually based. But before that, let's swing back. I said I'd just do a few of these. So the only difference from the so once we get into this, let's do that one, is that you're using base 3 now, and you're still keying in a ninth. 1 over 9. Okay, and you're getting -2 as your answer. So you're still using the log, but you're using the log to base 3, and the next one you'll be using the log to base 5, and the next one you'll be using the log to base 10. So say that one there. You go, well, what power do I raise 5 to? You raise 5 to whatever number it says here when I do 125 upside down. -3. Okay? So you can certainly see how there'll be tears and, you know, there'll be anxiety, stress, because I'm getting stressed doing them. And I know how to do them very, very well. Using the law, blah, blah, blah. So the distribution of powering over product. Verify each of the following. Verify. Okay, so the only way is to find what they come out as. So you calculate them in 2 different ways. So calculate 20 to the 4. Okay, which is 160,000. 160,000. And calculate 5 to the 4. So for some of us, we're getting used to, let me check something. Let me check whether I need my multiplication symbol here. Yeah, I do. I need something there.